Assalamualaikum warahmatullahi ta'ala wabarakatuh. Good day to each and everyone. So today's videos we will continue our discussion for our previous topics. Okay. So from our previous topics, we didn't finish our um discussion. Okay. So that's why in here we will try to finish it as much as possible. Okay, so before that, I'm always reminding you that please have your own copy of these manuals so that you have your basis when we are discussing these topics, and of course, use your own headphones to fully or to clearly understand what we are saying here. Okay, so okay, so continuing our discussion for this subject, we have here the ideal gas states. Okay, so usually, no, most probably, some of our substances are really um, are some of our substances, no, regarding on their characteristics are really studied using ideal gas states. No, usually, no, when they have a pressure that is smaller than the saturation pressure, okay, we generalize it as a ideal gas states. Okay, so kasi when you say ideal gas state, okay, most of the operations and assumptions that we are um, using during the solving problem or analyzing the situation or the state of a given substances is being reduced, no, or sometimes it is being neglected. Okay, so that's why the most important state or the most important assumption when there is no when the situation is being suited on the given situation required or state required in this ideal gas state is uh, we are using this one. No, we are using instead of using um, complicated solution. No, we are using this ideal gas state assumption. Okay, so yun. Now, um, most of our no graph that we are studied previously is based on this graph here. Okay, um, itong tatlong graph na to. Okay, itong tatlong graph. So, but um, I think throughout our discussion previously, we didn't have the basic idea or the characteristic of this graph. Okay, which is generalizes the idea about what is the use of this one in relation to the state, no, or in relation to its um simplicity. Okay, so as you can see here, kung babasahin natin tong graph na to, okay, kung babasahin natin tong paragraph na to, okay, this is just a characteristic that would be arises, no, here sa graph natin, no. So hindi na natin siya babasahin, so giving you a small or brief overview about this paragraph here, no. This is actually about this characteristic of this one. So as you can see here, for example, this graph of T versus V, or temperature versus specific volume, no, as you can see here, no, um during or when the pressure is moving from this line here papunta rito, okay, papunta rito, our um characteristic, no, of temperature and volume is in opposite. Okay, and then usually, no, the pressure in this case is moving from or actually starting from zero up to uh evaporated state of our liquid. Okay, dito sa part na to. Okay, So, and the same time, no, itong P and T diagrams natin, okay, which is the relationship between P and temperature at a constant or at a given specific volume. Our volume here is papunta from this pataas pababa, no? Opposite with this one kasi dito siya pababa, okay, pataas, okay? From bottom, no, pataas. Dito siya is from pataas up to bottom, okay? So we have here um as the volume, specific volume goes from the top papunta sa baba, the values also increases, okay? That's why, no, we have here an equation that is formulated using this graph here, okay? So we have here T is equals to A multiplied by specific volume. What do you mean by this one? Okay? So, ibig sabihin nun, the temperature, okay, in relation to the volume, okay, is increases, no? Ibig sabihin nun, kung ipapa-increase natin yung area or yung volume natin, when you say A is a quantity that designates the area for this close figure here, okay? So we have here, when you increase the volume or specific volume, the temperature also increases, okay? So as you can see here, okay? So yun, okay. So that's why in here, assuming that P is constant, for P is constant, okay, iba pala to. Itong TAV is ito pala yun siya. Itong graph pala, kaya pala opposite, no? So as you can see here, as T increases, okay, or as V increases, no, at a constant pressure, T also increases, okay, for P is constant. Same with this graph as 2.6 equation naman, no, B also stands for area inclusive by this graph here, okay, inclusive by this graph here na P and T graph. Now as you can see here, when you increase temperature, P also increases, okay, in relation to the area inclusive by this P and T. Okay? So that's actually uh generalize the idea of ideal gas law, no, when you as you can see here, no, itong equation na to, itong equation na T is proportional to V at saka P is proportional to T, makikita natin siya dito sa ideal gas law natin, no? We are all familiar with our ideal gas law. We have here PV is equals to RT. Okay? So as you can see here, P is proportional to T and V is also proportional to T sa T. Okay? Same with this one. T is proportional sa V, P is proportional sa T. Okay? So yun. So um So yun actually diyan actually na-derive yung idea ng ideal gas law, okay? So just read this one, okay? About this simplification of this formula of this ideal gas law, okay? So we have here example number 7. Sabi dito, what is the mass of air contained in a room of 6 by 10 by 4 if the pressure is 100 kilopascal and the temperature is 25 degrees Celsius. Okay? So in here, no, given yung volume natin, no, that is 6 by 10 by 4, given yung pressure natin, given yung temperature natin, and then assuming that at room temperature at a lower pressure, no, as you can see here, yung pressure natin is 100 kilopascal. Usually it is below from the saturated pressure. It means that we can assume here that it is a ideal gas, okay, state. So we can already use this equation 2.9, okay, equation 2.9, this equation 2.9 here. Okay, so that's why here, solving for mass here, since ang mass yung hinahanap natin dito, so mass is equals to PV over RT. So given yung R, given yung pressure, given yung V, given yung temperature natin, all we have to do here is to plug in the value. We have here the 280.5 kilogram. Okay, same with this one. So we have here a tank has a volume 0.5 meter cube and contains 10 kilogram of an ideal gas. So sinabi na niya rito, having a molecular mass of 24. The temperature is 25 degrees Celsius. What is the pressure? Okay? So as you can see here, yung R bar natin is given na actually doon. Tapos given yung molecular mass natin, na 24 kilograms. So we can, therefore, we can actually find the um, universal, okay, gas constant. Okay? So you have here 0.346. Okay? So ibig sabihin nun, no, may given naman tayo na mass. So we can directly find the value of our pressure. Okay? So same with this example, no, it is just expressed in a English unit, so please refer on it. So example number 9, no, we have here, it talks about the um, volume flow rate of our um, substance or gas, okay, um, using an assumption of ideal gas. Okay? So, parehas lang din to sa kanina, but dito kasi, sa mga examples natin dito, ang pinag-uusapan natin dito is that only the volume and the mass. No? Dito sa example number 9, we are talking about here the flow rate. Ibig sabihin nun, the changing of volume or the changing of mass of the substance with respect to time. Okay? So, but, same equation pa rin yung gagamitin natin, but it just that, as you can see here, nagkaroon tayo ng m dot dito at saka v dot signifies as it talks about the mass flow rate at saka volume flow rate ng isang volume. Okay, so basahin niyo na lang yun siya, parehas pa rin ng idea, so ganun pa rin yun. Okay, now, um, okay, so the question here now arises is that um, how can we assume, or what situation where we can assume that the substance is in ideal gas situation, or is in ideal gas state. Okay, so we can actually assume that the ideal gas, or the given gas is in a ideal gas state if and only if, okay, we have studied its compressibility factor. Okay, basically compressibility factor talks about how is the given substance deviates from the ideal gas state. Okay, so, ito yung pag-aaralan natin dito. Okay? Um, compressibility factors is equals to, as you can see here from this equation 2.12, compressibility factor is equals to PV over RT. Okay? Now, anong reason bakit ko sinabi na koan, no? This equation talks about the division of a substance from ideal gas state. It's because, no, as you can see here, kung yung z natin is assuming natin na 1 siya, no? 1, so ibig sabihin, this equation will result on ideal gas law. Tama? Okay, but if we assume that this z is below 1, okay, or less than 1, so we can no longer assume this as an ideal gas law. Okay? Ideal gas states. So, kung babasahin natin tong paragraph na to, so yun yung ibig sabihin nun. Okay? Now, we have here graph, or a simplification of a graph of a compressibility factor of nitrogen. Okay? So later, no, sa appendix D natin, okay? If you have already downloaded our PDF that we are using here, kindly refer on figure sa appendix D natin about the generalization of a division or compressibility factor of um, compressibility factor of substances. Okay? In here, para lang to sa nitrogen. Okay? So, okay. Now, from this graph here, we have here as observation, no? Uh, we have here observation from 1 to 3. So, we have here number 1. The first is that at all times, or at all temperature, Z approaches to 1 as P approaches to 0. That is, the pressure approaches 0. That is, the pressure approaches 0, the PVT behavior closely approaches the predicted by the ideal gas equation of state. Okay, so as you can see here, as Z, no, ito yung Z natin, ito yung Z natin, ito yan siya. As Z approaches to 1, no, our pressure also approaches to 0, no. Most of this graph here, itong 110 kilopascal, 130 kilopascal, 150 kilopascal, up to 300 kilopascal, as you increase, no, I mean, this not kilopascal, no, Kelvin pala. As you increase the pressure, this graph, I mean, as you decreases the pressure up to 0 megapascal, this graph approaches also to 1, no? As you can see here, they are all originated from 1 here, no? 1 um, scale here, no, for compressibility factor. Yun yung observation sa number 1. For number 2 naman, we have at temperature of 300 Kelvin and above, that is at room temperature and above, the compressibility factor is near unity up to pressure of about 10 megapascal. This means that the ideal gas equation of a state can be used for nitrogen, and it happens air over this range with considerable accuracy. Okay? So, at a temperature of 300 kilopascal, okay? 300 kilopascal, I mean, at a temperature of 300 Kelvin, that is above the saturated temperature, okay? We have here the graph, okay? The graph up, the graph of the graph is actually near at 1 compressibility factor. Okay, up to 10 megapascal. Okay, as you can see here, yung 300 kilopascal natin na graph from this one, I mean yung 300 Kelvin natin na graph from this one, okay, up to this one here is nearly its compressibility factor is 1, up to 10 megapascal. Okay? So yun. That's why, no, at this, as you can see here, yung 300 Kelvin na yan is yan yung room temperature natin. Okay? That's why kung meron kang given na nitrogen, okay? Kung meron kang given na nitrogen at this temperature, assuming that its pressure is below saturated pressure, you can assume that it is in ideal gas state. Okay? So yun. So, number third, at lower temperature at a very high pressure, the compressibility factor deviates significantly from the ideal gas value. Moderate density forces of attraction tends to pull molecules together, resulting in a value of Z is less than 1, whereas very high density forces repulsion tend to have the opposite effect. Okay? So, as you can see here, at this 110 Kelvin, 130 Kelvin, 500, 150 Kelvin, at saka 200 Kelvin, okay, as you increase the pressure, the graph deviates from this one here, no? So, ibig sabihin nun, no, ah, as the pressure increases, no, as the pressure increases up to hanggang sa malagpasan niya yung saturated pressure, we can no longer assume that it is an ideal state. Okay? So, yun. Yun lang ibig sabihin ng assumption number 3. Okay. So, this graph here talks about the generalization of our assumption, no? Ibig sabihin ito kasi siya is only used for nitrogen. Now, okay, sabi dito sa graph na to, no? Most of the substances that we are using in here is same with this graph of this one qualitatively. Okay? But quantitatively, not. Because, okay, they have different uh, critical situation. Ibig sabihin nun, for nitrogen at saka yung ibang substances, magkakaiba sila ng critical pressure at saka critical temperature. Okay? So that's why in here, in this graph, in this paragraph, we are using a reduced pressure to fully use the graph of appendix D.1, figure D.1. Okay? Yung tinatawag nating generalization of all graphs. So pakitingnan lang, no, kung meron kayong copy of this PDF, no, pakitingnan lang sa figure D.1. Okay? So yun. So, saan natin ginagamit tong reduced pressure and reduced temperature? So, we are using this reduced temperature at saka reduced pressure to assume or to see that if the given temperature, I mean, to see that if the given substance, okay, is if the given substance can be assumed as a ideal gas state, since no mas madali, okay, yung ideal gas state natin, okay, when it comes to the solving, okay, or when it comes to the understanding of what is the characteristic of a given substance, okay, kasi may mga nanineglect tayo na quantities, okay, when it comes to an ideal gas state, okay. That's why kailangan natin tong critical reduced pressure and reduced temperature, okay, to refer to the generalization graph, okay, generalized graph of all substances doon sa figure D.1 natin sa appendix D, okay? So yun. So as you can see here, reduced pressure at saka reduced temperature is related to critical pressure and critical temperature of a given substance, okay? By dividing the given pressure and the given temperature with the critical pressure and critical temperature. And after that, the result is reduced pressure and reduced temperature. Yan yung titingnan natin sa generalized graph natin doon sa figure D.1 natin sa appendix D to see if the situation are nearly at ideal gas state or not. Okay? So meron tayong different examples dito. So pakibasa na lang. Okay? And then if you have any questions about this, if you have any questions about this discussion or about these topics, you may just have to ask it to me through our group chat or through our Edmodo class. Okay? And any clarification, you may also raise it to me. Okay? So that's all. Assalamu alaikum wa rahmatullahi wa barakatuh.